The following is a selected video from YourTeacher.com, where you can browse over 450 complete math lessons with example videos, interactive practice problems, self-tests, and more. Try a complete lesson today at YourTeacher.com.
Graph the following quadratic function. Identify the vertex, minimum, x and y intercepts, axis of symmetry, one pair of symmetric points, and the domain and range. Compare the graph of the function with the graph of y equals x squared. First, we're asked to graph the function y equals x squared plus 2. To graph the function, let's start by setting up a table of ordered pairs, with the x values in the left column, x squared plus 2 in the middle column, and the y values in the right column. For the values of x, let's use -2, -1, 0, 1, and 2. If we plug a -2 into our function for x, we have -2 squared plus 2, or +4 plus 2, which is 6. If we plug a -1 in for x, we have -1 squared plus 2, or +1 plus 2, which is 3. If we plug a 0 in for x, we have 0 squared plus 2, or 0 plus 2, which is 2. If we plug a 1 in for x, we have 1 squared plus 2, or 1 plus 2, which is 3. And if we plug a 2 in for x, we have 2 squared plus 2, or 4 plus 2, which is 6. Now, setting up a coordinate system, we graph the ordered pairs from the table. -2, 6, -1, 3, 0, 2, 1, 3, and 2, 6. And connecting the points, we have a smooth U-shaped curve, which is called a parabola. Remember that the graphs of all quadratic functions are parabolas. Next, we're asked to identify the vertex of the parabola. Note that the vertex is either the highest point or the lowest point on the parabola, depending on whether the parabola opens upward or downward. In this case, since the parabola opens upward, we can see that the vertex is the lowest point on the parabola, which is 0, 2. Next, we're asked to identify the minimum value, or the smallest y value, of the function. It's important to understand that the minimum value always comes from the y value of the vertex, which in this case is 2. So the minimum value, or smallest y value of the function, is 2. This should make sense because we can see that no point on the parabola has a y value that is less than 2. Next, we're asked to identify the x and y intercepts of the parabola. Remember that the x-intercepts are the points where the parabola crosses the x-axis. And notice that the parabola does not cross the x-axis. Therefore, there are no x-intercepts. Remember that the y-intercept is the point where the parabola crosses the y-axis, and notice that the parabola crosses the y-axis at the point 0, 2. So the y-intercept is 2. Next, we're asked to find the axis of symmetry, which is the fold line for the parabola, or the line that splits the parabola down the middle, which in this case is the y-axis. And the equation of the y-axis is x equals 0. Next, we're asked to find one pair of symmetric points. We can see from the graph that the points shown in green represent a symmetric pair in relation to the y-axis, or the axis of symmetry. and these points have the coordinates -1, 3, and 1, 3. Another way of finding a symmetric pair is to use the ordered pairs in the table. Remember that the y values of symmetric pairs of points are the same. Therefore, the points -1, 3 and 1, 3 are a symmetric pair because they each have a y value of 3. So whether we use the graph or the table, we can see that one pair of symmetric points is -1, 3 and 1, 3. Next, we're asked to find the domain and range of the function. The domain of a function is the set of all x values of the function. Remember that the x values on a coordinate system are the left and right values, and we can see that the parabola is expanding infinitely to the left and to the right. So the parabola will cover all x values on the graph, which means that the domain of the function is all real numbers. And the range of a function is the set of all y values of the function. Remember that the y values on a coordinate system are the up and down values, and we can see that the parabola is expanding infinitely upward, but notice that it never goes below the y value of 2. So we say that the range of this function is y such that y is greater than or equal to 2. Finally, we're asked to compare the graph of the function with the graph of y equals x squared. Remember from the previous example that the graph of y equals x squared, or the parent graph for the family of quadratic functions, is a parabola that opens upward with a vertex at the point 0, 0. So the graph of y equals x squared plus 2 is simply the graph of y equals x squared translated or shifted 2 units up on the y-axis. In other words, the plus 2 after the x squared term shifts the graph 2 units up.